Hello, Algebra students. Welcome to one of the easiest lessons of the year. This lesson we're going to cover in just one video, lesson practice and everything. And the reason this is so easy is because it's something we just did. This video is not different from when we were adding real numbers. Subtraction is addition. Remember, I keep saying that all subtraction is addition. So we're going to learn in this lesson why I keep saying that. And that's what we're going to be focused on, subtracting real numbers in this lesson. But the first thing we need to do, let's define what opposites are when we're talking about numbers. Two numbers that are opposites have the same absolute value, but different signs. 1, -1. Same absolute value, different signs. 5, -5. Could be irrational too. Pi, -pi. Square root of 2, the negative square root of 2. Anytime you have a number and the same number but with a negative in front of it, we call those two numbers opposites. By the way, that works with fractions also. That's one example I didn't give. 1/2 and -1/2 would be opposites as well. Okay, so another name for an opposite of a number is its additive inverse. And the reason we call it that, an inverse in math usually refers to an operation that undoes another operation. And when we think of it in that terms, it makes sense because the number 2 kind of undoes the number -2. So anytime we have two numbers that are opposites, we say that one number is the additive inverse of the other. 2 would be the additive inverse of -2. Or I can say it the other way around. -2 is the additive inverse of 2. All right, so that brings us to our inverse property of addition, which is actually our rule that we need to do subtraction. When I say all subtraction is addition, this is the reason why. For every real number a, remember it's a real number, so it could be a fraction, it could be a square root, or it could be just an integer. For every real number a though, a plus the opposite of a equals the same thing as the opposite of a plus a, which equals 0. When you add a number to its opposite, you get 0. So let's take a look at an example of that. If we take the number 5 and we add the opposite of 5, we get 0. If I take the number 1/2 and I add the opposite of 1/2, I get 0. Pi plus the opposite of pi gives me 0. That's the inverse property of addition. One of the simplest properties, mathematical properties to work with. Okay, now, what about rules for subtracting real numbers? To subtract a number, you simply add the numbers, but you don't just add them straight out, you add the inverse. Then you follow the rules for adding real numbers. Do you remember those rules for addition? In addition, if you have two numbers that have the same sign, you simply add the numbers and then keep the sign for both numbers. So -2 plus -3 is the same as 2 plus 3 is 5, but then I keep the sign of my original numbers, which was -5. When I add two numbers that have different signs, I find the difference between the two numbers, and then I keep the sign of the number that had the greater absolute value. Okay, so we have those rules for adding numbers. Subtracting is the exact same thing. We add the inverse and we just follow those rules. Here's an example. 3 minus 5 is the same as 3 plus the inverse of 5, -5. So 3 plus -5. Well, I have to follow those rules for adding numbers. So that means I find the difference between 5 and 3. That is a difference of 2. And then I keep the sign of the number that had the larger absolute value. 5 has a larger absolute value than 3. It had a negative sign, so I'm going to keep that negative sign, -2. And that's it. That's the lesson. So let's go ahead and work some examples, because actually this lesson is way easier to understand if we work some examples. So letter A, 14 minus -22. But wait a second, to subtract two numbers, I just add the inverse. So whenever I subtract a negative, it's the same as just adding numbers. Minus the opposite is taking the opposite of the opposite, which is positive. So instead of 14 minus -22, this is actually become 14 plus 22. But the way to think through it, like we were thinking through things in this lesson, is that this is 14 minus the opposite of 22, which becomes 14 plus whatever the additive inverse of -22 was. But -22's inverse is +22. So this is 14 plus 22. Same thing. which means that it's going to be 36. So subtracting the opposite of something is really easy because in the truest sense, that subtraction problem becomes an addition problem. And I'm just adding two positive numbers. All right, let's take a look at letter B. -7 minus 16. Well, I'm going to add the inverse of the second number. So I'm going to change it to an addition problem. Plus, so it's -7 plus 16. Okay? Now I could just use my rules for addition. I'm going to find the difference between 16 and 7. 16 minus 7 is 9. And then I'm going to keep the sign of the number that has the greater absolute value. 16 has a greater absolute value than 7, so I'm going to keep the positive, not the negative. My answer is going to be 9. Letter C. This one takes a little bit more work, okay? Because for this one, we've actually got a subtraction problem. And I'm going to set it up like a subtraction problem, but instead of a subtraction problem, we need to make it an addition problem, and I'm going to add the inverse. So this should be -23.4 minus plus the opposite of 18.72. I'm just noticing I set this one up entirely wrong when I preset this one up. So we're going to fix it as we go here. So when I do this problem, I'm going to end up adding these two negative numbers together. And let's see what happens when we add these numbers. Now, they have the same sign, right? Negative. So I'm just going to add them, not subtract them. So let's see if I did this right. 0 plus 2 is 2. 4 plus 7 is 1, and then I have to carry a 1. I carried that first one here separate, okay? So 8 plus 3 is 11, plus 1 is 12, carry another 1. And then 2 plus 1 is 3, plus 1 is 4. So it's going to be 42.12. And then I need to make sure that I keep the sign of the original. So this isn't just going to be 42.12. It's going to end up being -42.12. And that is the correct answer to this. So I add, instead of a subtraction, where I see the subtraction sign here, I added the opposite. And then I just follow the rules for addition. Same with this last one. Here I have a fractional problem with rational numbers. So -2/3 plus 1/6. Instead of subtracting -1/6, I'm going to add the opposite of -1/6. So plus 1/6. Well, this simplifies. Let's see, actually, before I simplify it, I have to get a common denominator. So I'm going to multiply -2/3 by 2/2. That gives me -4/6. Now, when I add fractions, I'm going to add the numerators following the rules for addition, and the denominator just stays the same. The denominator is going to be 6. -4 plus 1, they have different signs, so I'm going to find the difference is 3. And I keep the sign of the one that has a greater absolute value, which is 4. So this is going to be -3/6. And I see that this is going to simplify to -1/2, because 3/6 is the same as 1/2. And that's my answer. All right, letters E and F are a little different. It's asking me to determine whether the statement is true or false. So these are these sets being closed under operations statements. So let's just think about these two. Letter E, the set of whole numbers is closed under subtraction. By the way, do you remember that everything was closed under addition? Addition was a really simple operation. Subtraction is a little bit more complicated. Can the set of whole numbers be closed under subtraction? Well, if we think about it, if I subtract like 5 from 3, do I get a whole number? 3 minus 5. 3 and 5 are both whole numbers, but when I subtract 5 from 3, I get a negative number, which is no longer whole, it's an integer. So we would say that this is a false statement. The simplest example is just 1 minus 2. 1 is a whole number, 2 is a whole number, but when I subtract them, I get a number, I did that wrong, there we go. I get a number that's not a whole number, -1. So therefore that's false. However, the second one, the set of rational numbers, I can't subtract two rational numbers and get anything but a rational number. I'm just thinking of some examples, like 2 minus 3 is still a rational number. If I do 1/2 minus 1/8, I'm still going to end up with a fraction. There's nothing that's going to change it from a fraction to a non-repeating, non-terminating decimal or anything. So because rational numbers contains all positives and negatives, there's no way I can use subtraction to change anything from a rational number to something irrational. And then letter G. There are multiple ways you could do letter G and answer correctly. I'm going to show you a way that's probably not the preferred way, but it's a way that works with what we did in this lesson, okay? So we're going to say that because the Trieste is diving to a depth of 37,800 feet, we're going to make that a negative number. It's diving to negative 37,800 feet. It's below sea level, so it should be negative. The previous record was 13,800 feet less. And again, this is 13,800 feet downward, less than the dive on January 23rd. What was the record set on January 7th? Okay, so we're looking for the old record that's 13,800 feet less than the current record. Well, here's how I'm going to set this one up. Okay, I'm going to set it up by doing negative 37,800 feet, which is the original dive. This is the dive on January 23rd. Maybe this isn't the original one. This is the most recent one, the record-setting one. I'm going to subtract from that the difference between the two dives. But because that difference is a negative number, it's down, it's a depth, it's negative. So I'm going to subtract negative 13,800. And I can do this one without actually having to set this up as a long addition problem. Because I'm going to change this now to plus, the opposite. So it's going to be 37,800 plus, and then I'm going to add the opposite, plus 13,800 feet. Okay, when I do that, I'm going to end up finding the difference between these two numbers. I find the difference between these numbers is 24,000. And then I need to keep the sign of the one that has a larger absolute value. 37,800 has a larger absolute value, so I'm going to keep it negative. So the original dive was negative 24,000 feet. So this maybe seems a little confusing. And what I'm going to encourage you to do, these are easy problems to do. But as you do them, I want you to complicate them a little bit just to make sure that you're keeping things straight. What I want you to keep asking yourself as you work the problems in this lesson is, what does this look like if I'm adding the opposite instead of subtracting? I want you to show your work, and I want you to show your work adding the opposite instead of subtracting. That's what's going to be required for numbers 1 through 30 for next time.